Okay, 7.5, we're going to go over properties of logs and condense and expand using those properties. And then we're going to use the change of base formula, which is super simple, okay? But the first section, we're giving you, or I'm going to give you certain things that you have to just know with logs, okay? So remember that last class we talked about with logarithmic equations, you can use log base solution equals exponent for you to get to its exponential form, right? Because they are inverses of each other. So if I give you log base 6 of 6, ignore that I already told you it's equal to 1. If you didn't know what it was equal to, okay, imagine that this was an x, okay? So we could put it in exponential form. Log base, so my base is 6, solution equals exponent, so 6 to the x is equal to 6. And then they're the same base. This has an understood exponent of 1, so there's my x equals 1. That's why log base 6 of 6 equals 1. Now, I don't want you memorizing log base 6 of 6 equals 1. I want you memorizing the rule log base b of b is equal to 1. So that base could be literally anything, and that solution position could be the same number and it equal to 1. So log base 7 of 7 is 1. Okay? Then if I have log base 3 of 3 squared, okay, so again, imagine if this was just an x. Putting that in exponential form, I've got my base of 3, my exponent of x, equal to 3 squared. Well, that one-to-one property tells me x equals 2. That's where that 2 came from. Again, I'm not telling you to memorize specifically log base 3 of 3 is 2, but log base b of b to the n power is always going to equal that exponent. Okay, so these are the general rules that I want you memorizing. Those are just examples proving why. Okay. Natural log of e equaling 1, we did that last class. Just to refresh your memory, again, if that would have been an x, e to the x, because I have an understood base of e, is equal to e. Well, that's understood to be 1, so that's my x equals 1. Okay, same thing with log of 10. That is equal to 1. Okay, I don't have that up there, but that's the same concept as natural log of e equaling 1. Okay, the natural log of 1 equals 0. My base is an e. Imagine if this were an x, so e to the x is equal to 1. The only way you're getting 1 from any base is if that exponent is 0. So y'all had something like that on a previous homework where it was, I think, 7 to the x equals 1. So that's the only way you're getting that 1 is if it's 0. Okay? So natural log of 1 is 0, log of 1 is 0, all of those apply. Okay? So that's something that you're going to need to know and apply for future examples. Okay, then we're going to look at the properties of logs. So remember, logs and exponents are inverses. So I'm going to use examples of exponents to kind of correlate with those logs. So if I had the product property of exponents, okay, so if I had x to the third times x to the fourth, what would I do with those exponents? I would add them, 3 plus 4 to give me 7. So when I multiplied like bases, I added exponents. So with logs, if I'm going to multiply two things in a log, then I can separate it with a plus. I could add them. Okay? Now, it seems weird to do that, but this is, if we go from here to here, that's expanding. So we would know, hey, I'm multiplying, that means I'm going to separate it with a plus. Okay? If I go from here to here, then I know the moment I see a plus, I'm multiplying the two together. Okay? Now, my quotient property, think about exponents. If I had x to the 5th over x squared, I would do what with my exponents? I would subtract them. Same thing here. If I am dividing, then I subtract when I expand. If I see a subtraction symbol, that means I should have a fraction because I divided. Well, you won't have a fraction every time, but you're dividing. Okay? Now the power property is if I have log base b of m raised to the p power, all that's happening is that outer exponent comes in front and is now a coefficient being multiplied by the log. Okay? So those are my three properties that I'm going to use for the next two sections to expand and condense. Okay, so my first section, I'm expanding these expressions using those properties. So what that means is I'm going to look at each term, and so log base 6 of 5x cubed over y. Technically, I have three terms here. I have a 5, an x cubed, and a y. Okay, so when I'm expanding, each individual term should have its own log. So my final answer should have 3 logs written. Okay, now this log base 6 goes to all of them. Okay, now once you get the hang of it, you should be able to look at it and go straight to the final answer, but that's not what I'm looking for your work. Okay, so at some point you're going to separate the terms and then you're going to keep separating from there. That's your expansion. Okay, so if I have log base 6 of 5x cubed divided by y, a good clean spot to break it would be right at that fraction, right at that division. Okay, so I'm going to have my log base 6 of 5x cubed. Now division means what operation when I expand it? Subtract. So I'm going to put minus y. No, minus log, my bad. Log base 6 of y. Okay, so each term has its log. But I need to go ahead, now that I've separated the fraction, I need to separate 5 from x cubed. So I'm going to have log base 6 of 5, and then what operation? Plus log base 6 of x cubed minus my log base 6 of y. Okay, now I can't box that in because I have one more thing to take care of. I have an exponent. That exponent comes in the front. So I have log base 6 of 5 plus 3 log base 6 of x minus log base 6 of y. Now I'm done. So I know this is easy once you do so many examples that you should be able to take care of some things in one step. Just be very careful skipping. I do not want to see you go straight from here to here. I want to see the separations, okay? This one, we're going to ignore that it's 5x cubed because we just did 5x cubed. So let's say we do log of 1/2 x to the 7th. Okay, where would I separate that? The 1/2 and the x to the 7th, and I know it's multiplication, so whenever I expand it, I'm going to use my addition, so log of 1/2 plus. Now this is okay if you go ahead and move that exponent if you know you should. That exponent comes out front, 7 log of x. That one is something that's simple. I'm okay with that. But you're not going to do more than 2 things in one step. Okay? So my next one, natural log of the cube root of x to the 5th. I know in radical form, I can rewrite that in rational exponent form. Right? What is that as a rational exponent? Natural log of x to the what? 5 over 3. And then what do I do with that? That exponent goes in the front. Could I have specified and made you simplify this and then break it apart? Yes, but I'm fine with just doing this 5/3 natural log of x for right now. You just have to know how to convert. My goal there is for you to remember how to convert from radical back to rational exponent. Okay? So this next one, where am I going to break it? Right there at that fraction. So I'm going to have log of x cubed minus log of 2y to the 5th. Okay? Now I need to break 2y to the 5th. In the same step, I can also bring that 3 forward, but I need to break this 2 from that y to the 5th. Okay? So I'm subtracting the entire 2y to the 5th. So when you break that apart, you have to be careful to make sure that you have the right sign. Most people know how to do this, and they have a minus log of 2, but then they put a plus y to the 5th. But I'm not multiplying by y to the 5th for my original problem. I'm technically dividing, right? So that minus goes to each term in that denominator. So I'm going to have minus log y to the 5th, which again, I've got an outer exponent that needs to come forward. So 3 log x minus log of 2 minus 5 log of y. Okay? So what I want you to know, because a lot of people make that mistake often, not just once, but often, if you have something in your numerator, you should have a plus in front of that term. If you have something in your denominator, you have a minus. So if I have 5 terms in my denominator, I should have 5 subtraction symbols in front of each term. Okay? So knowing this is going to help you for when you have something like this. You have to see it as, I really am dividing by y to the 5th. If I had a plus at y to the 5th, that means it would go in the numerator. Okay? You understand the difference there? Okay. So now when we're condensing, we're going from multiple logs down to 1 log. So I'll do 2 things at a time, and I typically work left to right. Okay, so if I'm looking log of 3 plus 3 log of 4, well, I know that this 3 goes to 4, okay, as an exponent. So I'm taking log, and I know it's a plus, so I'm multiplying 3 times 4 to the 3rd power minus my log of 6. Okay. Well, 4 to the 3rd power is what? 64. 64 times 3 should be 192. So I've got log of 192 minus log of 6. Well, that minus log of 6 tells me I should have what? I'm dividing 192 by 6. So then my final answer would be log of, should be 32. Okay. So then my next example, I've got coefficients for all 3 terms. So all 3 of those are going to be made the exponent. Okay, so I'm going to have natural log. I'm going to take 5 and square it, and then that plus tells me I'm multiplying that by x cubed minus my natural log of y to the 6th. So 5 squared times x cubed is the natural log of what? 25x cubed minus my natural log of y to the 6th, which, what am I doing with y to the 6th? I'm dividing 25x cubed by y to the 6th. I know a lot of you like to skip steps. I would not recommend skipping too many steps in these sections. It's easy. It's an easy section, but it's easy to mess up. Okay, little mistakes will get you. Alright, so this next one, I've got 2, then parentheses, log base 3 of 10 minus log base 3 of 5, plus 0.5 times log base 3 of 9. Okay. My first step, what do you think I'm going to take care of? My parentheses. What's inside parentheses? Because that's my order of operations. Okay, log base 3 of 10 minus log base 3 of 5. Your instinct is going to want to be log base 3 of 5. Because 10 minus 5 is 5, right? Logs do not work that way. Okay, what does a minus tell me? I'm dividing log base 3 of 10 by 5. And I'm going to go ahead and move that 0.5 to the 9, so log base 3 of 9 to the 0.5. Okay, well 10 divided by 5 is 2. And what do I know about this 2? So I've got log base 3 of 2 squared, which is 4, plus log base 3. Now this 9 to the 0.5 is really what? It's 9 to the 1/2, which is the square root of 9. What do we know the square root of 9 to be? 3. Now technically plus or minus 3, but are we going to consider the negative? No, you can't take the log of a negative. So I'm multiplying 4 times 3. So I get log base 3 of 12. Do we understand condensing and expanding? Do we have questions? Okay. So now this section is where I give you a specific piece of information, the value of a log or 2 logs, and we have to evaluate this new log. Okay, so evaluate each of the following using the given information and the properties of logs. Show all required work. Only use numbers that are the base and numbers that are in the solution position for the log or the natural log. That's important. Okay. So if I have log base 3 of 5 is approximately 1.465. All that means is I rounded it. Okay. And then that's my given, and I need to find log base 3 of 45. So what we're doing in this section is we're manipulating this number that we're trying to find in terms of the number that is in the base or the solution position. So I can manipulate 45 in terms of 3 or in terms of 5 using my properties of logs. Okay? So what do I know about 45? I can split that into what? 5 times 9. Okay? Well, if I know I'm multiplying, I'm basically expanding here. I'm multiplying 5 times 9, so I will have log base 3 of 5 plus log base 3 of 9. Okay. Now, I said I can work in terms of 3 and a 5. Well, I've got this log base 3 of 5, so I'm good there. But I don't have a 9 listed. I can't work with 9. So what could I do further? 9 is what? 3 squared. Okay, so I can make this log base 3 of 5 plus log base 3 of 3 squared. Or you could do another 3 times 3 and split it with a plus. Okay. Now, log base 3 of 5, I can substitute 1.465. But what do I do with log base 3 of 3 squared? You can do 2 things. You can bring the 2 forward and then look at log base 3 of 3. Or, remember that I said log base b of b to the n is always m. So that means if I have log base 3 of 3 squared, this is really just 2. So then that is 3.465. So if I'm working with a number that's in terms of the base, because I'm not given that specific value, then you're going to use one of those properties I did at the beginning of the section. Now if you moved your 2 forward and you had 2 times log base 3 of 3, well, log base b of b is always 1, so 2 times 1, there's also your 2. So you could have done it either way. Okay? So then my next one, I give you 2 logs. Log base 4 of 5 is approximately 1.161. Log base 4 of 15 is approximately 1.9534. And I want to know what is the log base 4 of 5 over 16. Okay? Now, what would your instinct be for that 5 over 16? I would split it. So that could be log base 4 of 5 minus log base 4 of 16. Okay? Now that log 4 of 5, I'm good because I know that value. Log base 4 of 16, I need to manipulate. This log base 4 of 15 is not a typo. It's just extra information. Just because I give it to you doesn't mean you need it. Okay? What can I do with 16? 4 squared. So log base 4 of 5 minus log base 4 of 4 squared. So this is 1.161 minus what? 2. And that answer would be 0.839. Do y'all understand that? These are easy examples. Your worksheet might need you to manipulate a little bit more, but you should just be understanding how to separate and use your properties. Okay? So now I've got log base 12 of 8 and log base 12 of 10, and I want to find log base 12 of 80. What do you think I'm doing there? Split it to what? This is 8 times 10. So I've got log base 12 of 8 plus log base 12 of 10. So 0.8368 plus 0.9226. $1.7594. We're good with that? Okay. Last 2 examples. Change of base formula. You need to know it. You've got to memorize it. I'm not going to give it to you, but it's so easy. Okay, if I have log base c of a, and I want to change the base to natural log, then my formula is log of a divided by log of c. I now put it into a common log, and I get the value. If I say I wanted a natural log, then you do the same type of formula, just natural log of a over natural log of c. So it's the log of your solution over the log of your base. Okay? So use a change of base formula to evaluate the logarithm. Round answers to 4 decimal places. Show all required work. So if I have log base 3 of 8 and I want to use the change of base formula and I don't have any specifications, that just means I'm making it a common log. So log of 8 divided by log of 3. And I would just type that in my calculator. So I'm going to get my fraction, and then second, that PRB button under the percentage button gives you your log. So log of 8 divided by log of 3. And 4 decimal places would get me where? 1.8928. So then I've got log base 8 of 14, and I want to change it to a natural log. That means I'm going to do natural log of 14 over natural log of 8. So the same buttons, you just go to the right to get your natural log. And that will be y'all have any questions on this? Okay. Y'all will have 7.6 next class, and then a quiz over 7.5 and 7.6 combined. Okay, so not just this, but combined with 7.6.